past experience of a large manufacturer firm with administering a test to recent college graduates who had applied for a job revealed that the mean test score was 500 and the standard deviation was 50. The distribution of the test scores was normal. So we have the mean 500 and we have the standard deviation 50. We need to calculate what is the probability of having a score less than 470. We are going to solve this question using normal distribution function in Excel. So I like to have my answer here. So I'll insert function. I'm looking for normal distribution. The value of our variable is 470. The mean is 500 with a standard deviation of 50. We are looking for a cumulative probability. So it's true. So 27.43% of graduates will have a score less than 470. In Excel, we are reading the cumulative probability for less than a value, so we can read this probability directly. For part B, they ask to calculate what is the probability of having a score more than 586. So more than 586 will be in the upper side of our diagram because the score is more than the mean. Once more, when we are reading the probability in Excel, we are reading the cumulative probability for less than that value. We are looking to be more than this value, so we are subtracting from total probability, which is 1, the value that we are reading in the table. Why? Because we are looking to calculate for more than 586. What we read in Excel, we are reading for less than 586. Total probability is 1. So if we subtract from total probability of 1, probability of being less than 586, we are calculating probability to be more than 586. Again, I'll go in insert function, normal distribution. So the value is 586 this time. The mean is still 500. The standard deviation is 50. And we have cumulative, so it's true. Once more, this probability is what is probability to have a score less than 586. To be more than 586, we have to subtract from 1 this value. Minus this value. So the probability will be 4.27. So probability to have a graduate with a score more than 586 is 4.27. For part C, they ask what is the probability of having a score between 450 and 578. 450 is below the mean, and we can read this probability less than 450 directly from the normal table. For 578, similar, we calculate what is probability to be below 578. We are interested between 450 and 578. So if we subtract from the probability below 578, probability below 450, we have the probability between 450 and 578. So we are calculating first probability to be below 450. So we are going in insert function, normal distribution. So this is 450, the mean 500, and the standard deviation 50. is true. It's cumulative. Now we are calculating what is probability to be less than 578. So again, insert function, normal distribution. We have 578 with a mean of 500, a standard deviation of 50, and it's cumulative. So again, we are interested in the area between 450 and 578. So if we subtract from this area below 578 the area below 450, we have the area in between. So our probability will be the value that we have in cell D5 minus the value that we have in cell C5. If we express as percent, so it is 78.19. So 78.19, we have a probability to have a score between 450 and 578. For part D, they ask, based on this experience, management is considering placing a person whose score is in the upper 5% of the distribution directly into a responsible position. What is the lowest score a college graduate must earn to qualify for this position? So we are looking to calculate the z-score, the cutting point between the upper 5% and the rest of 95%. Because in Excel we are reading the probability to be below this value. So right now we have the probability and we are looking to calculate the value of x. It's the inverse situation that we had before. So I'll insert this time normal inverse function. So we have normal distribution and we have normal inverse. Once more, upper 5% means lower 95%. Because in Excel we are reading below that value, so the probability that I will include in my table is decimal 95. We are having a mean of 500 and a standard deviation of 50. So the test score corresponding to the upper 5% is 582.24. So a student will qualify for that position if the minimum score is 582.24.